All right, going to review a really important concept here, and that is how to find an A value for the two parent graphs that we studied that have A values. The two parent functions that we're looking at today are the absolute value function, quadratic function, parabolas. So in the absolute value function, the A represents the slope of the rays, because an absolute value function is like a piecewise linear function, two different pieces of lines. So when you're looking at the graph and you want to find A for an absolute value function, that's actually pretty easy. You can either count the rise and the run to give you your slope, or you can use the slope formula. If you've forgotten the slope formula, oh, I will be very sad, but here it is. M equals y2 minus y1 over x2 minus x1. It's change in y over change in x is slope. So let's take a look at that. In example 1, we've got two different absolute value functions, and we want to be able to write the equation. Now, all I talked about here is how to find the A. You should know what the equation looks like and how to find the rest of it. Absolute value functions take the form y equals a absolute value x minus h plus k, where hk is the vertex. And we already discussed a is the slope of the rays. So in example 1, part A, I can see where my vertex is. This is my vertex. Its coordinate is -1, 4. So that means when I go to put that in, I've got y equals my A, and then I've got x minus -1, absolute value, plus my k, which is 4. So now I need to find my A, and I need to simplify. So to find A, I'm going to use a different color here. I'm going to count the rise and the run. Here's an exact point right there. So rise is right here. My rise is -4. I went down 4 units. My run right here, I went in a positive direction 1 unit. So my rise over my run, in this case, is -4 over 1, which would be -4. So that means that this is my A value. Now, depending on which ray you count, if you get a positive slope, you have to know that, remember, the A determines the direction of the opening. So because this one opens down, you have to take the -1 because the other ray has a slope of +4. So you need to know, based on whether it opens up or opens down, whether it's positive or negative. So this stays negative because it opens down. So that means that our final answer when we're writing the equation is y equals -4, absolute value, minus negatives become pluses, so x plus 1, and then plus 4. So that is our equation for A. All right, B, you are going to do yourself. Do not leave this blank. Make sure that you actually complete it if you want credit for your notes tomorrow. So that one is for you to try on your own to see if you can do that. All right, so now let's look at quadratic functions, because this one's just a little bit trickier. The quadratic functions, because they're not lines, they're parabolas, A is not a slope. And the quadratic function, we had many different forms. We had ax squared plus bx plus c, which is standard form. We had vertex form, which is y equals a x minus h squared plus k, very similar to the absolute value, so that's vertex form. And then we had intercept form, which was y equals a x minus p times x minus q. So the a value here is not a slope because these aren't linear. The only way to find a that is going to work every single time is to pick a point on the graph and plug it in for x and y, because every point has an x coordinate and a y coordinate. So if you have a point on the graph, you can plug it in. Now, here's the key. You can't pick a point you've already used in the equation. So, for instance, if you're writing an equation in vertex form, you've already used the vertex as one of the points. You can't use it again for x, y. You would have to pick a different point other than that. Same thing with intercept form. You've already used the two intercept. You have to pick a different point in order to plug it in for x and y. So let's look at a couple of those in action. So on A, and it says, write the equation for the given quadratic in the indicated form. So here I'm saying I want you to write it in standard form. Okay, so as we are looking here, I almost always use vertex form. Sometimes I use intercept form if I can see very clearly exact intercepts, but most of the time I use vertex form because the vertex is relatively easy to identify. Here's my vertex. My vertex is at -1, +2. I can't go directly to standard form. So I have to do vertex form first. There's no way to get directly to standard form from this. So I start with vertex form, and I say, okay, I know that my h is -1 and my k is 2. In order to be able to find my a value, because right now I know that it's going to look something like this, x minus -1 squared plus 2. But I need to find my a. So in order to find my a, I need to have something to plug in for my x and my y. So I need to find another exact point on the graph. So there's a couple of them to choose from, but I'm going to choose this one right here. That's the point 1, 3. So 1, 3 is also on the graph. That is going to be my x and my y. So now I'm going to plug those in. So y is 3, a is what I don't know, x is 1, so I've got 1 plus 1 squared plus 2. So 3 equals, 1 plus 1 is 2, 2 squared is 4, so 4a plus 2. So now I'm just solving for a. Subtract the 2, divide by 4, a is 1/4. So now just put that back in to your equation and simplify. So y equals 1/4 times x plus 1 squared plus 2. Now, if this said vertex form, I would be done. But it says standard form, which means I actually need to multiply all of this out. So x plus 1 squared is x squared plus 2x plus 1. So now I need to distribute that 1/4, which is going to give me 1/4 x squared plus 1/2 x plus 1/4, and then don't forget this plus 2 that you had out here. So when I simplify everything, I've got y equals, this is my only x squared term, so 1/4 x squared. My x's, this is my only x term, so plus 1/2 x. And then I've got 1/4 plus 2. 2 and 1/4 as an improper fraction is 9/4. And so there is my standard form equation. All right, let's try this again. This one should be easier because this says vertex form, which means I don't need to multiply anything out. So I look here. Here's my vertex. It's at 3, and in this case 5 is the y coordinate. So I know I'm going to need another point. So this one, actually, I can use the same point I used last time. That's 1, 3. So this is my xy. This is my hk. Now just plug them in. So y3 equals a x plus or minus, see, I'm already messing up, minus k, which is 3, plus k, which is 5. So here's my h, here's my k, here's my x, here's my y. Now I'm going to simplify. So 1 minus 3 is negative 2. Squared is 4. So I've got 3 equals 4a plus 5. So subtract the 5 on both sides. Negative 2 equals 4a. Divide by 4. A equals negative 1/2. And again, because it says vertex form, that means all I need to do here is plug in that a to x minus 3 squared plus 5, and I am done. There is my equation. All right, how about intercept form? This is the one some people forget, but it's a really easy one to use. Intercept form, I've got two intercepts here. So 3, 0 is one of my intercepts. Negative 1, 0 is the other. These are my P and my Q. The order is not important. If you made the 3, 0 P and the negative 1, 0 Q, that's fine too. So I know that I'm plugging in to y equals a, x minus p, x minus q. So y equals a, x minus 3, x minus negative 1. So it looks like this. And I need my a. So I need another point, one that I haven't already used, to plug in for x, y. Well, I haven't used the vertex, so I'm going to go ahead and use it. That's at 1, negative 4. So this now is going to be my x and my y because there is no h and k in this equation. So y is negative 4. A is what I'm looking for. Then I've got 1 minus 3 and 1 plus 1. So 1 minus 3 is negative 2. 1 plus 1 is 2. So I've got negative 2 times 2, which is negative 4. So here I've got negative 4 equals negative 4a. So divide by negative 4. Ooh, moved that over accidentally. Negative 4 over negative 4 is positive 1. So a is 1 in this case, which means y equals, you don't have to put the 1 in front. It's just going to be x minus 3 times x plus 1. And that's it. All right, this last one is also for you to do. Do not leave it blank if you want credit for these notes. So it says standard form. Remember, that's going to be just like what we did in A. You're going to have to do vertex form first. After you find your A, plug it back in, and then you'll have to distribute. So please finish D, and don't forget example 1B. Those need to be complete if you want credit tomorrow. That is it.